Hi, everyone. Welcome back to Dave's Math Channel. I'm your host, David Tear, and today I thought I'd do another number theory video. Today I'm going to talk about amicable pairs, and I have to tell you what those are. I will in a minute. Anyway, on the slide I show the first 13 amicable pairs, but I'll define them. So anyway, let's begin. So what is an amicable pair or an amicable number? Well, these are very closely related to perfect numbers. You probably know that a perfect number is a number such that the sum of all the non-trivial divisors, either divisors not including the number itself, is equal to that number. And the smallest perfect number is 6. After that, 28. After that, they get very, very rare. And similarly, we can divide amicable numbers. We say that we have an amicable pair, A comma B, if the sum of the non-trivial divisors of A is equal to B, and similarly the sum of the non-trivial divisors of B is equal to A. So whereas with the perfect numbers, it takes just one step to get back to the number if you're adding the sum of the divisors, non-trivial divisors. In the case of amicable numbers, it takes two steps. And there's also numbers called sociable numbers where it takes more than two steps. I'm not going to talk about those in this video. But anyway, let's just talk about amicable numbers. So it turns out that the smallest amicable pair is the pair 220 and 284. You can check this yourself. If you add all the non-trivial divisors of 220, you get 284, and if you add all the non-trivial divisors of 284, you get 220. And this turns out to be the smallest pair with that property. And like I was showing you on the opening slide, there's exactly 13 amicable pairs, all of whose both of whose members are less than 100,000. So there's one pair up to 1,000. I think there's uh, 5 pairs up to 10,000. There's 13 pairs up to 100,000. They're pretty rare, and but they're not that rare. They're actually much more common than perfect numbers. It turns out, and you'll see big, huge lists of them. I mean, there's literally there's over a billion known now. I'm gonna get to that in a minute, but how do we find these things? Well, these have been an interest ever since ancient times, and there was actually, I think, in ancient India, there was a method discovered, Taba ibn Qurra theorem. That might not be in Indian. That might be Persian, actually. But it turns out that there's an algorithm, or not really an algorithm, but there's a theorem that says that if you have these three prime numbers p, q, and r of this special form, p is equal to 3 times 2 to the n minus 1 minus 1, q is equal to 3 times 2 to the n minus 1, and r is 9 times 2 to the 2n minus 1 minus 1. If we have three primes of this form, then it turns out that I think it's 2 to the n times p times q and 2 to the n times r is an amicable pair. And actually, Euler used this rule. Euler was a very famous mathematician, you probably know, from the 18th century. He actually found, I think, 61 amicable pairs of this form, and even generalized this rule a little bit. I think he found three additional primes with his generalization. Most of them were of the original form, but he found 61 amicable pairs, all of his form. Some, I think the largest of which were pretty large. I don't know how many digits, probably millions, maybe even billions of digits. But I mean, not billions of digits, but in the billions. But something interesting happened. It turned out that the second smallest amicable pair, 1184 and 1210. This was discovered by a kid in 1860. It was an Italian 16-year-old kid. He was just playing around. I guess he was just adding factors of small numbers, maybe not that small, but he got up to 1184, and then he discovered the sum of the non-trivial divisors of 1184 is 1210, and then it's vice versa. The sum of the non-trivial divisors of 1210 is 1184. So I think it's kind of weird. I mean, from I think Euler and there were several other famous number theorists who discovered some really large amicable pairs, but it turned out they missed some very small ones, including the second smallest. And this is what's known as exotic amicable pair. It turns out that most amicable pairs, I don't know if it's most, but a lot of amicable pairs have a formula you can use to calculate them. Maybe not Euler's formula. But then there's these other pairs called exotic pairs, and these don't really have a formula. They're just kind of weird. They just happen to be amicable, but there's no good reason for them. And then so after that, several more were discovered. As a matter of fact, I think the largest number on this list, the largest pair on this list, the 13th, this was only discovered in 1964, I believe, and it was the first one discovered with the use of computer. So we even needed computers to find all the amicable pairs up to 100,000. This wasn't even done until 1964. So maybe there's some really big ones known before then, but we didn't even know all the ones up to 100,000 until 1964. But then as computers have gotten a lot faster, more powerful, according to Moore's law. And now, I mean, this is just a bigger list. I don't know when this list was completed, but this is a list of all the amicable pairs up to 20 million, and there's already, I guess over 100 of these. So the number of them grows pretty fast, even though they're kind of rare. They're not really that rare, and this table kind of shows you how many there are. It's not, no, what's interesting is that it still hasn't been proven there's infinitely many amicable pairs. I think just about all number theorists who've studied them believe that there are infinitely many. And you can see that up to a trillion, there's 7,632. It looks like the number in each power of 10 bracket grows by about a factor between 2 and 3. So it seems to obey some kind of power law. Roughly maybe the cube root or something like that. So it looks like the number of amicable pairs, I call that A of n here. Looks like A of n is about approximately the cube root of n. But nobody's proven this. I mean, there are sort of heuristics on how many amicable pairs there are up to a given bound, but nobody's proven it. And there's currently over a billion, like I said earlier, exactly 1,228,964,779 known amicable pairs, and I'm sure they're being discovered every minute, so this number probably isn't even current. I went to a website that has a database on all of these, and they're constantly being discovered. But as of this video, this is how many that are known, and the largest of these is a pair, each of whose members has 56,260 digits. So these things can get pretty damn large. And there are a few conjectures about amicable pairs. Like I said, it's conjectured there's infinitely many, although we don't know that yet. That hasn't been proven. It's also been conjectured that all amicable pairs consist of a pair of either both even, or both odd. And odd amicable pairs are kind of rare. They're not really that rare. I mean, I'll show you the first one, actually. It's not even that small. Which one is it? Forget which one. Oh yeah, the seventh amicable pair, 12,285 and 14,595. That's the smallest odd amicable pair, and I think this was only discovered in 1939. And I don't know. I don't even know if I think that there's a finite fraction of all amicable pairs that are odd, but I think it's less than 50%. But what's not known yet, and it's suspected that there's no pair of amicable numbers where one is even and the other is odd. That hasn't been proven, but I think just about all mathematicians believe that there are no amicable pairs like that. I guess that's kind of like whether or not there's an odd perfect number. Most mathematicians don't think there's any odd perfect numbers, but that hasn't been proven. But anyway, I guess that's all I have to say about amicable pairs. Anyway, thank you for watching. Long live math, and I'll see you guys next time. Bye.